Welcome to the DIY Honda Garage channel. The DTC P0A11 indicates a malfunction in the DC-DC converter activation circuit of the Honda CR-V 2023 Plus. This diagnostic trouble code, DTC, arises when the Powertrain Control Module, PCM, is unable to receive a boost demand notification from the DC-DC converter, leading to a stored error. The DC-DC converter is responsible for converting high voltage from the vehicle's battery to a lower voltage, enabling the operation of various electrical components. Its location is typically near the vehicle's battery and is connected directly to the PCM, which is the brain of the engine management system. The PCM plays a critical role by monitoring the circuit status and activating the DC-DC converter as needed. When this communication fails, the PCM stores the DTC as a signal of an abnormality, initiating further troubleshooting procedures. The error, represented by DTC P0A11, highlights an issue where the PCM does not receive the necessary boost demand from the DC-DC converter. The DC-DC converter is essential for transforming high voltage from the vehicle's high voltage battery to lower voltages that various electronic systems require. The PCM, or Powertrain Control Module, governs the operations of the engine and electric systems. Its role includes assessing signals from the DC-DC converter and ensuring it operates accordingly to maintain vehicle functionality. The DC-DC converter is usually located near the vehicle's battery, while the PCM is often found in the engine compartment within a waterproof housing for protection. Together, these components work to maintain power distribution and vehicle integrity, making their proper function essential for overall vehicle operation. When diagnosing DTC P0A11, it's vital to consider several potential causes. First, wiring issues may arise, where broken or shorted wires could prevent communication between the DC-DC converter and the PCM. Next, the DC-DC converter itself may be malfunctioning, resulting in its failure to send boost demand notifications. Lastly, the PCM could be at fault. If the PCM's own operational capabilities are compromised, it will be unable to interpret or respond to signals from the DC-DC converter. Each of these components must be systematically inspected to determine if they are functioning correctly, as they play integral roles in the vehicle's electrical system. The symptoms associated with DTC P0A11 may manifest in several ways. Drivers might notice poor electrical performance, such as intermittent operation of electronic devices like infotainment systems or headlights. These issues often tie back to the inability of the DC-DC converter to supply adequate voltage levels required for smooth operation. In addition, battery-related problems may arise, such as difficulties starting the vehicle or diminished battery charge. Frequent warning lights on the dashboard, including those related to charging systems or general electrical failures, can also signal underlying issues. Observing these symptoms can help technicians focus on the electrical system, particularly the DC-DC converter and PCM, during the troubleshooting process. The first step in troubleshooting DTC P0A11 involves a test drive of the vehicle. This practical assessment helps verify whether the error actively presents under normal driving conditions. Following this, the engine must be stopped using the auto idle stop feature, if equipped. This action is crucial because it allows for the PCM to reset and recalibrate and check if the DTC reappears. It's an essential diagnostic step that serves to confirm the presence of the issue, while also establishing a baseline for later inspections. The behavior of the vehicle during this process can also provide insights into the severity of the circuit malfunction, In the second step, focus shifts to inspecting the external circuit, particularly the DC-STS circuit. DC-STS refers to the DC-DC status, and its proper operation is critical for effective communication between the converter and the PCM. The inspection should verify that all connections are secure and that there are no signs of wear or damage to the wiring. Referencing diagrams for the connector pinouts can help ensure a comprehensive inspection. Perform tests to confirm continuity and check for any open or shorted circuits that could affect current flow. This step is fundamental as it establishes whether the problem lies in the circuit itself or in the components connected along that path. The third troubleshooting step involves inspecting the DC-DC converter itself. Since there is no straightforward method for testing it directly, the best practice is to utilize a known good component. Replace the suspected faulty DC-DC converter with a functioning one and observe if the symptoms change. If the vehicle no longer triggers the DTC after the replacement, it confirms that the original converter was defective. However, if the DTC persists, the issue may lie elsewhere, possibly in wiring or the PCM. This component testing is critical for accurate diagnosis, ensuring systematic elimination of possible faults. The final step in troubleshooting DTC P0A11 requires inspecting the Powertrain Control Module, often referred to as PCM. If preliminary inspections indicate that other components, including the DC-DC converter and circuit connections, are functioning correctly, it implies that the PCM may be defective. Testing involves confirming that the PCM interacts properly with other vehicle systems and receives inputs as expected. Using advanced diagnostic tools can help uncover any issues within its programming or hardware. Once any malfunctions in the PCM are identified, appropriate measures can be taken, such as reprogramming or replacing the unit. This step is crucial as the PCM controls and manages many critical functions in the vehicle. After completing all necessary repairs and inspections related to DTC P0A11, the next step is to perform final verification. Start by clearing the stored DTC from the PCM using a diagnostic scan tool. Following this, it is essential to retest the vehicle under the same conditions that previously elicited the DTC. Monitor for any reappearance of the error to confirm that the original problem has been successfully resolved. Should the vehicle operate normally without returning the DTC, it indicates that the troubleshooting process has been effective. Documenting this verification step is also crucial for maintaining service records and ensuring comprehensive understanding for future reference. Preventive maintenance plays a vital role in reducing the likelihood of DTC P0A11 reoccurrence in the future. Regular inspections of the vehicle's electrical systems can help identify potential issues before they escalate into more serious problems. Pay specific attention to wiring quality and connections associated with the DC-DC converter and PCM. Ensuring that these components are kept clean, free from corrosion, and securely connected is essential for reliable vehicle performance. Additionally, keeping abreast of software updates for the PCM can improve its operational efficiency and reduce the chances of communication errors. By actively engaging in preventive measures, vehicle owners can greatly enhance the longevity and functionality of their Honda CR-V. Understanding DTC P0A11 and its implications is vital for effective vehicle maintenance and repair. This diagnostic trouble code is a signal of communication failure between the DC-DC converter and the PCM, indicating potential electrical issues that must be addressed. By following the thorough troubleshooting steps outlined, from testing vehicle operation to inspecting individual components, technicians can accurately pinpoint the problem. Prevention through routine inspections and maintenance can significantly mitigate the risk of similar codes arising in the future. Ultimately, a proactive approach not only resolves current issues, but also fosters a better understanding of the vehicle's electrical systems and enhances overall reliability. Please like and subscribe to the channel. See you next time.